Hello everybody. So our today's question is find first and the last position of element in an sorted array. So let's read the statement. Given an array of integers nums sorted in ascending order, find the starting and the ending position of a given target value. If a target is not found in an array, return -1 -1. Okay, I think you understood what is the statement, and you must write an algorithm with the O of log n runtime complexity. So we are going to use here binary search approach. So the people who don't know about binary search, they will get to know about what is binary search and how we'll apply that. So let's read the test case. First test case: 5, 7, 7, 8, 8, 10. Target is 8. So you have to return the first occurrence of 8. Okay. The first occurrence of 8 is this. That is at position 3, 0, 1, 2, 3. Yeah. And the last occurrence of 8 is 4, 3, 4. Okay. So that is answer. Now in this case, target is 6. So I don't find any target here, so you have to return -1 -1. In this case target is 0, output -1 -1 because there's no just target. So let's go to editor and check how we'll do it. File, okay. So now what is the 5, 7, 7, 8, 8, 10? 5, 7, 7, 8, 8, 10. So firstly we see how do we approach the solution. Okay, firstly we will apply the binary search here. So how binary search works? So what we do, we will find the mid element of the current array. So suppose mid element of the current array is like 0, 0 plus 5. Okay, so 0 plus 5 by 2, that is 5 by 2.5, that is 2. Okay, suppose the mid element comes this 7. Now we will check. Now we will check whether it's equal to 8 or not, because target is our 8 and the target as well. So it's not equal. So what we will do, we will simply discard the, and also we'll check that whether this number is greater than target value or less than target value. So if this number is lesser than target value and the array is sorted, so I know that the target value will not come on the left side of the array. So we can simply discard the left part and we can go on the right part, and we will find we will check the mid element of this part now. Now this part, the mid element is 8. Okay. Now, so if you found it, now first case is you have to find the left one. Okay, first case you have to find the leftmost occurrence. Now if you have found the 8, okay, target element, now you will check whether the present position, whether the previous position from the current position is equal to target or not. For example, in this case we find the mid. Okay, that is 8, and that is the position of the 8 is 4. So whether the previous position, that is equal to this, whether it is equal to 8 or not. So I found that yeah, it is equal to 8, and so this is not my answer, because you have to find the first occurrence, and first occurrence will be like this one. Okay, this one will be first occurrence, because on the left hand side there is 7, so the first occurrence will be this. Okay, so for the left part I know this is 8, and the first occurrence of 8 will come on left part. Okay, I think you understand, because this sorted array, so it will not go on the right side. 8 will come on the right side, but we have to find first occurrence. Okay, then we will just simply discard right side. Okay, then only two, then this array is remaining. Then we will go then find the mid element of this array. Then we'll check that this is the mid element. Okay, then only one element remains in an array, that is this 8, and we will check that the present position, that is equal to 3, and 3 minus 1, that is equal to 2, and at position number 2 there is 7. and which is not equal to 8. So this is my required answer. That is for the left, for the first test case, my required answer is 7. Sorry, this position number 3. Similarly, we will do for the right occurrence. So for the right occurrence, suppose we have found that 8 here, and the right occurrence, like the next position to this 8 is 10. This is not equal to 8. Okay, so this is my answer. So in this way, we are applying binary search here, and binary search works as like we just simply discard the half of the array. Okay, every iteration we discard the half of the array. So what is the time complexity of binary search? Suppose uh, at last, suppose we have done kth iteration. Okay, so at last we will just get half of the array. Okay, 2 की power k is k, sorry, equal to 1. Okay, at last you will get only one element. That is my answer. So n upon n is equal to 2 की power k, and k will be like equal to log of n base 2. Okay, so that will be a time complexity. So in first test case we will find the left part, and in second test case we will find the right part, and we will return the answer. Okay, I think you have understood what is the solution and how does it work. And keep one thing in mind, we have to find some condition, because it's a sorted array, so we have to find some conditions so that we can apply, so that we can discard half of the array, and the time complexity will be log n. Let's go to solution. We'll solve the question. Mm. So what we want? Okay, firstly we'll check. We will write left. Okay, left equal to 0, int right equal to nums dot size -1. Okay, now we want answer as well, so we have to return the answer in the vector form. So I will take one vector int answer. Now in first test case we have to find the leftmost occurrence. Okay, in the leftmost occurrence, what we do, hmm, uh, let's say run a while loop here. L is less than equal to r, less than equal to r, and now we have to write the condition. So as I've told you that the first occurrence will come, suppose, okay, we have to find the mid first. Int of mid equal to L plus R by 2. Sorry, to write it like this. Okay, int mid is equal to L. And the condition is if nums of mid equal to target. First, this condition should satisfy. Okay, then what we do? Okay, then we'll check nums of, and also what I said, that nums of mid -1 not equal to target. Okay, that is condition. So if I got this condition, what I will do, I will simply show the solution. So the solution will be answer dot push underscore back the mid. Okay, and simply I will break, and now I will write the else condition here, else if condition here. Now suppose if nums of mid greater than and equal to target. Okay, and I know that, okay, it is equal to target, and when it is greater than target, and then I know that the first occurrence of the current number, that the target will be on the left side of the array, because it's sorted, and it is greater than, then it's be on the left hand side, and if it's equal to, then also we have to go on the left hand side if the previous condition was not satisfied. So, so what I will do, I will simply r equal to mid minus 1. I think you can understand. If you don't understand this thing, just tell me in the comments. I will just clear your doubts. Else, what we will do, uh, L equal to mid plus 1. Okay, I will just simply copy paste here. Okay, one more thing. Suppose if this mid minus 1 is like negative, then it will the index will overflow. So I have to write one more condition here. Okay, here. So I can write here is like mid minus 1. Okay, suppose if mid is 0, okay, only one element is present. So what I can do here is mid minus 1, what I opened, sorry. Mid minus 1 is equal to minus 1. I think you know what I why I have did this, because if mid is 0, so that is my last that is the first occurrence. Okay, that is the first occurrence. So I will not go on the left hand side of that particular occurrence. So I will just simply or mid minus 1 not equal to target, so that only one condition should satisfy. Either it's the first element of the array, or it's a, or either it is in some between. Okay, so I will do like this. Or I will simply copy paste this, and for now this was my first case for the first occurrence, and now I will do for the second occurrence as well. So now again I have to change the value as L equal to 0. Okay, then R equal to nums dot size minus 1. Okay, now this is, so now condition will change here is like condition will be like, okay, num target and mid. Now you have to check name mid plus 1 equal to nums dot size, because if it's the last element, so I got the element, and that will be the last occurrence of the particular element, and so I have to change here as well, mid plus 1, and answer this. And now if it is, now I have to change condition if it is lesser or equal to target. Okay, so you just analyze that. Okay, just analyze that if it's lesser than equal to target, then it will be on the right hand side of the particular index. You have to analyze it. The last occurrence will be on the right hand side of the current index. Okay, so what we'll do, so our left means our left will be equal to mid plus 1, and our right will be equal to, in the last case, that will be equal to mid minus 1. You understand this thing? Simple binary approach. I have done nothing else. Okay, and then when I got this answer, then I push this mid as well. Okay, so, and in the question statement it is written that if the target is not found in the array written minus 1 comma minus 1. Okay, I have to add one more thing. Suppose, okay, I will write an integer value find, okay, equal to 0. I will just simply do find plus plus. I have done this to check whether the element is present or not. Okay, if the element is not present, so I will simply written minus 1 minus 1. Now I will check if find equal to 0. Okay, if find equal to 0, the return minus 1 comma minus 1, else return else return answer. Okay, let's return answer. I think there's nothing mistake here. That's equal to R, and I will, okay, this is my mistake here. This is my mistake here. I missed one. Okay, plus plus break. And okay, let me check on the code as well. Check any mistake, any solution error. Okay, it's accepted. Submit. Yeah, it's accepted. Runtime is 40 milliseconds. So I think you understood the solution. If you feel anything that you did understand, just tell me. And if you are thinking then why I have not written find plus plus here, because if I have got any occurrence, then that will be work. Then that will work for me on the left or for the right. because if there's only one occurrence, then the left and the right will be same. Okay, that's why I've written only for the left part. Find plus plus. Find is equal to 0. The match one. And one more thing, one can think to do as well, like this. If you found, like, suppose I want to tell you one more thing. If you are thinking like, let me just remove. I will just one more. No, okay. So now suppose you have 8, 8, 8, 8. In the worst case, till n. Okay, n is very big. Now what happens is, like, when you got mid, some somewhere like this, you have got mid. Now if you are thinking that, okay, one by one I will go to this, to this, to this, and check whether the previous element is not equal to the current element. So in the worst case, you have to search for n. Okay, you have to go for n. Okay, O of n, the time probability O of n. So you don't have to do this thing. Okay, because one may think we can do like this also. So if you just got the element, just we go, no, the worst case you get time complexity O of n. So simply just split into, okay, in the first case and second case, and simply apply binary search here. I hope you understood this thing. Thank you very much, and see you in the next question of LeetCode. Bye bye.